Math 76, Lesson 64, Prime Factorization, Division by Primes, and Factor Trees. So this is all one topic, which is prime factorization, and we've got two different ways to do it. I like to call it the division tower or the factor tree. So let's go into that. What prime factorization is taking a composite number, which is a large number, or well, any number that can have more than two factors, or any number that's not prime, and rewriting it in factors that are prime. So for example, if I were to take the composite number 4 and write it in prime factorization, 4 would be equal to 2 times 2. 2 is a prime number. 2 times 2 equals 4. I've taken the number 4, I've rewritten it in prime factorization. Or like the number 6. 6 is a composite number. If I rewrite it in prime factorization, it's 2 times 3. These are both prime numbers, and they equal 6. So it's finding prime numbers that multiply to the number that you've written. And essentially all I'm doing is I'm taking the number 6 and I'm rewriting it. So I'm not changing the number, I'm rewriting it. Now let's talk about our two steps to do prime factorization, because this is easy. We can see how to do this 4, 6, 8, 9. What if I tell you to do the prime factorization of the number 60? Well, that's where factor trees and division towers come in. I'll show you division towers first because they have more rules. Then I'll show you factor trees last because that's my favorite way to do it. So the way division towers work is we have to take our number 60 and I have to divide it by a prime number. I can only divide by prime numbers on division towers. If I divide by composite numbers, I will get a wrong answer. So what is a prime number that can go into 60? Well, as you can see, 60 is an even number. It ends in 0, so I can divide it by 2. So I'll divide by 2. All right, so 2 goes into 60. Let's see here, 3 times 0. Okay, so now I've got 30. And what I'm doing is I'm taking my answer and I'm building another division house. See, this is what I call a division tower. We're just going to build it up and up and up, just like the ziggurats that you learn about in history. Now, 30 is also an even number, so I can still divide by 2. How many times will 2 go into 30? Well, that's 1 this time, and then 5, so 15. Well, can 2 go into 15? No, not anymore, but I know it can. 3. 3 can go into 15. So now I will divide by 3, because 3 is still a prime number. 3 goes into 15 5 times, and 5 is a prime number. So the way a division tower works is you divide by prime numbers until you end up with a prime number on top of your tower. Now what this tells me is all of these numbers outside the tower, that is my prime factorization. So the number 60 can be rewritten as 2 times 2 times 3 times 5. So right there, 1, 2, 3, and 4 numbers. So, and then I'll show you that on a calculator, because some of you might be thinking, what? Is that the same number as 60? Let's do it on a calculator. Let's do 2 times 2 times 3 times 5. All right, that's our prime factorization, right? What does it equal? It equals, whoops, a glare on the screen. No, it equals, so hard to see with the cameras and the shadows and the light right above my 60. There we go. I found the right angle. So it equals 60. You are not allowed to use calculators. I'm just using this to show the example. Now, that's how division towers work. Only divide by prime numbers until you get a prime number on top, and that is how you rewrite the number. Now let's talk about my favorite method, which is factor trees. The way factor trees work is I just ask myself, what times what can equal 60? And I factor my trees, I factor the tree into stems and leaves until I have prime numbers at the end. So let's see, there's a lot less rules on factor trees. I just have to get prime numbers at the end of all my branches. And that'll make sense as we do it. So we ask ourselves, what times what equals 60? Well, 6 and 10. That will equal 60. Now, are either of these numbers prime? No, they're not. So I'm going to factor again. Put a factor tree here and a factor tree here. What times what equals 6? Well, 2 times 3. Hey, are either of these numbers prime? They are. So whenever I get to prime numbers, I circle them. Now let's see here. What times what will equal 10? 2 and 5. Are those numbers prime? Ah, yes they are. So I circle them. Now when all of my answers are circled, or when I've got no more numbers to factor, then that is my final answer. I take all the circled numbers and I put them in ascending order, meaning lowest numbers first. So I do 2, 2, 3, and 5. which is the same answer we got over here. So I like factor trees a lot better because there's less rules, and I'll show you what I mean by that. So I can do factor trees multiple ways. Let's say I didn't think of 6 times 10. Let's say I did 2 and 30, like on the previous problem. I could have put 2 times 30, and then I asked myself, hey, is 2 a prime number? Ah, yes it is. Okay. And then let's say I got to 30, and I thought, hey, I know 6 times 5 will equal 30. So I could have put 6, and I could have put 5, and I said, hey, 5 is a prime number, so I circle that. And then I could go even another level, and I go, okay, well, what times what equals 6? 2 and 3, hey, those are both prime numbers. Now I look at all my circled numbers. Well, I've got 2, 2, 3, and 5, which is still the right answer. All right. So I like factor trees because they're a little bit more versatile. There's more room for thought in factor trees, whereas division towers are very, very precise. You have to do prime numbers the whole way. But that's prime factorization. That's how we do division by primes. If you guys have any questions, let me know on Moodle, and I will see you in class.